Okay, hello. We're back again. We're still in the office, and I was just thinking about what else I could show you that I've made towards this endeavour. And my materials calculator, I thought, woohoo! Look, I wrote this because I thought I could, and I don't get to use formula and Excel spreadsheets for work or anything like that, and I don't enjoy it as such. But I suppose I do enjoy it a little bit. I enjoy making things work. I like it when the code works. I like it you know, x equals 4, and when it actually comes out and x does equal 4, it's good when it actually works, and I enjoy that. So I made this material calculator in Numbers, which is Mac's version of Microsoft Excel. It's a spreadsheet, uh, a program for making spreadsheets, I suppose. You can get free versions of these products like LibreOffice or OpenOffice, both very good products. They're open source, so once again, they're not hacks. These things, if I say it's a free product, they are genuinely free products written by volunteers as such, not dodgy copies with keygens or anything like that. But I wanted it to work on my iPhone. I have an iPhone. All you Apple haters out there, I'm sorry, but I like Apple. And Numbers works on iPhones, so I paid the £13, I think it was, or something for Numbers, and now I had this program. So what did we? What's the point? So other people can work this out. You can go on. There's an online website called Source for Me or Source for You or something like that. Which is it's just got this on a web page. You go in and type stuff, and it will tell you how much stuff you need. And I did go on there, and I've used their product calculators, and at some of the times that's how I found out their conversion rates. Other times I just spoke to bricklayers or people who've done it for years and asked them. But I came together with this, and we'll start with the aggregates calculator. It's the most basic of them all. The length you input in these yellow boxes. We'll say we're doing some hardcore, or sub-base, I suppose might be the American term. Crushed concrete, or hardcore, as it's called over here. We've got a space that is, well, say 8 metres wide, length in metres. 8 metres wide, it's 5 metres, 8 metres long, it's 5 metres wide, and I want a thickness of 100mm, 4 inches. That tells me, very basically, and you see down here in the formula, B2 times C2, which is C2, that times that gives me a square meterage. Yes? Fair enough. And then I want to times all of that by D2, which is this in millimetres, divided by 1,000, so I get it into a metre. So that's in brackets. So that times that in brackets equals the cubic meterage. Done. Right. Tonnage required. This is where it gets slightly more complicated. Which is E2, what we've just worked out to be the cubic meterage, times conversion from M3 to tons hardcore. Now, conversion rates, another page I put in here. Hardcore, conversion from metre cube to tons. It takes, roughly, and you can find this out on Source for me, I'm not giving away any secrets here, 1.8 tonnes of hardcore to fill up a cubic metre. It just does. Sometimes it's a bit more, sometimes a bit less, depends how much it weighs, depends how wet it is or anything like that, but roughly. So that tells us we need 7.2 tonnes because of that times that. The tonnage ordered, so I've essentially taken this number, 7.2, and ceiling in numbers means round up essentially by a factor of quarter, 0.25, because you can only buy it in quarter of a tonne. You can't buy 7.11 tonnes, you buy a tonne and a quarter or a tonne and a half. So that's just a little function to tell you, you can see that. It doesn't need to say this, but it helps for the later part. You're going to have to order 7.7 tonnes. Now in here I have got a Carl and Bircher skip prices because they were the company who we use locally. They're not paying me to say. I haven't even asked them if I can say this, I suppose, but they sent me this. I just phoned them up and they sent me their price list. So this isn't, this is not trade prices. This is just a person. That's the cost of their skips. Where the hell is their? Oh, yeah. Sorry, I managed to get this bit off online. which was good, and told me the price of their skips, but I didn't want to know the price of their skips. I wanted to know the price of their hardcore. So he did send me the file by email, but I haven't got that here. It was just a picture, not a spreadsheet. Hardcore prices. If you buy a ton of hardcore, it is whatever. I don't know if these are even accurate. They're just numbers I put in. But 1 ton of hardcore costs you £34 a ton. If you buy 5 tons, it goes down to £17 a ton. If you buy 9 tons, it goes down to £16.56 a ton. You know, the more you buy, the cheaper it gets. Fair enough. But how do I make the program know that? Here we are. Price to the nearest quarter of a ton or meters cube. It takes the tonnage ordered. Now this is it's slightly more complicated, but I'm going to run you through it all. I'm going to tell you. If functions, it's a function that is used in computing code. It means give it something. Say, look, if this is true or this is what I say it is, do one thing. If it's not, do something else. It's just how it is written. There's probably better ways to do this, and there are better ways to do this with VLOOKUP tables and other things, but this is how I wrote it this way. I only had 3 numbers to work with. So G2, where the hell is G2? G2's here. If G2, the tonnage I need to order, is less than 3, surely that should be 5. I think that should be a 5. It gives me my number, whatever it is, the tonnage required, times the price for 5 tons. No, the price for 1 ton. So anything up to that will be a ton price. If not, so the next comma, do another thing. So if it's not, check, is it less than 9? Yes, it is less than 9. So it will put times by the, the 5 tons bit. Because it's already gone past this. It hasn't given you a number yet, so you know that's false. So it must be between 5 and 9. Yeah, so you pay the £5 price. And then it does it again, so if it's neither of the last two, it tells you times by the 9 ton price. That is how you'd write it. It's not secret. It just takes a lot of working out. I didn't just type this down, job done. It took a lot of working out, but I got there in the end. So that gives us a ton for that, and it does the same for sharp sand, building sand, concrete, and screed. Screed only does by these two by cubic meters, because I don't need to order tons of concrete. I order cubic meters of concrete and screed. And then these are just times 20%. So that's how I worked that bit out. That was the aggregates calculator. Then I wasn't quite done there because I thought, how else can I do a stud work calculator? Good idea. I've got a wall that is, we'll say 3 meters long. We've done length in millimeters in this because there was something later on that just wouldn't work. The wall in millimeters is 3 meters long wall. It's 1.8 meters high, 6 foot ish. There are no intersections and no corners. These you have to add studs for because of plasterboard pickups and stuff. So they are being taken into respect. Once again, you put inputs are the yellow boxes, and that will tell you all from just that, which is quite good. The area of your wall, one side, which is 5.4 meters. The number of studs if you had them at 400 mil centers, so 16 inch. These are the American version or the imperial version. Studs at 600 centers, you need this many. Length of the ordered studs. So once again, that is checking. It's rounding up to the nearest foot because you can't. You can only buy studs and stuff like that in foot lengths. So that's what size you actually need. Because if this was 1570 or something like that, you'd still be buying 1.8. So it tells you that. The length of plates in meters is 3 meters. So the total length of plates and dwangs, or I like calling them dwangs now because it's a funny word, but commonly known as noggins. It's bits in the middle that stop your studs twisting. Total length, that is 9 meters because you've got one top, bottom, and middle. And if that goes above, I think I've made it above 2.4. I've added another row of dwangs or noggins. So there's another little lookup function in here. All these ifs and complicated bits for no apparent reason, but that's what they do. They put another row of noggins in if it gets too long. From the area, you can work out how many sheets of plasterboard it is. A sheet of plasterboard is 2.88 square meters. It just is. If you divide 2.4 by 1.2, times them, you get 2.88 square meters. That's the size of a bit of plasterboard. It tells you if you want to do one side, you would need this much stuff. Once again, the bags of thistle. It's written on the bag how much multi-finish will do in square meters. So these are just basic conversions, and then it rounds them, divided by 3. Essentially you get about 3 boards to a bag, and then I've rounded that up to the nearest whole integer because you can't buy half a bag. Plus board screws, you don't need to know this is rubbish, but I just put them in because you can, they're just little bits of working out. Then I had the prices of plasterboard and skim. I haven't actually got prices on plasterboard and skim. These are just numbers I've put in to make sure everything works. But it's like I said, I haven't actually had to use this. I just made it because I could. And it's on the Dropbox. I will give you all a link to where this is. Bricks and blocks calculator. Bricks are a certain size. If you look online or whatever brick you're buying or whatever you're doing, it'll tell you how big the brick is, and you can work out a square meterage from that. Also, there's just, go and count a brick wall. Draw a square meter on it. Length of wall meters, height of wall meters. Has it got a cavity? Makes no difference to any of this apart from just a yes or no factor. Strength of the mix, so 5:1 would be your sand and cement or whatever you want to do. I didn't actually carry on with this brick and block prices because once again I didn't need to. I've already got my bricks. They're outside. I don't need to know how much it would cost if I did it with a different type of brick. There's no need for that. And then that'll tell you all this stuff. Area of the wall, how many bricks there are in a skin. If it's an on-inch wall, you need 2 skins. The blocks per skin, so if it was brick and block. Tons of sand. You can go on Source for Me or other places, or just ask a bricklayer how many tons of sand does it take to lay a brick, or how many bricks do you get to lay per ton of sand. Then the kilos of cement for the bricks takes in the strength of mix factor. Hang on. But yeah, none of this is trade secrets. This is all available on Source for Me. But I just wanted to make a program to do it all. So I could just type things in, tip, tap, tip. How much of what am I going to need? And it's here. And once again, it does run on my phone. Very good. Then came to the fun part. And I enjoyed this bit quite a lot because it was a challenge. A hell of a challenge, really. Pitch finder. It's basic. If you've got a run of whatever. What is it doing? Yeah, you've got a run of 5 metres and a rise of 4.2 metres. You can work out using trigonometry of a tan and -1, blah, 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 the pitch. It's not basic trigonometry. No trigonometry, basic as far as I'm concerned. But that's just what it is. And I found a massive issue with this numbers, and I don't know if it's the same with Excel, but everything works in radians, so you have to put it into degrees first and then do your functions. That was a nightmare. Either way, here we go. The roofing calculator. It's still a work in progress, but I'm really quite happy with this. You've got a roof that long, you've got a pitch, this much of a pitch. If you don't know the pitch, put your stuff over there and it will tell you your pitch. The run of the roof, which is obviously half your span, it says right there. And if you buy a roofing ready reckoner, which I have got and I use on site and I have done for a few years now, I like them. It works it out, but I've always known there's just an algorithm behind that book, and I wanted to prove that I could write it. So you get the timber thickness, and this is all, you don't need to know any of this. It just tells you what you need to order if you were ordering it. Look, usually the project manager will use a product. You can buy apps that do all this. Either way, tells you the area of the roof, which helps you work out for felt and battens and so on and blah, blah, blah. Number of your common rafters. Exact rafter length. This is the bit that's the complicated bit. This is where you would need the roofing ready reckoner or another app to tell you these measurements. If you want to work out a roof from just measurements, as in not having the ridge in front of you and being able to measure down to the plates and actual physical things to measure, and you need to work it out on paper first, the roofing ready reckoner on its pages has essentially got the conversion. Where is it? Roofs per meter run. There's a load of other stuff from 0.8, 0.9. There's a load of other stuff, but the one I needed to work out was the times 1 meter. So for every meter of run, how long is my rafter exactly? And that wasn't too hard, really. I mean, I've got an A level in maths. I'm done maths. I'm quite good at maths. But either way, I don't. Can I explain trigonometry here? I don't know if I could be bothered. Either way, because I know the length of run and I know the angle, I can work out the other bit. I need to know this number, and you can work this number out. It's not impossible. You tell it the angles, which is why I've just got all the angles down here. And of that angle, I need to know the cosine of it times, well, this is the really annoying part, this pi times 180. That is working in radians. And I don't like working in radians. It's really, really annoying. But essentially, this is giving me the cosine of this in degrees. So all that bullshit there is in degrees to the common of 3. So it's 1 over cosine, blah, 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 blah. I'm not teaching. I refuse to teach you the trigonometry at the moment. And that gives us this length. Hooray. Now comes the really complicated part. The really, really complicated part, which took me hours. And I do mean hours, and I really didn't need it to take me hours, because I could have just literally looked in the book, or I could have copied these 75 numbers, and it would have taken me 5 minutes. But I didn't. I spent 4 hours working out how it's done. And it's done like so. That one line of code took me 4 hours to get right. I'm not going to go through it. I might do one day in a special roofing calculator video, but right now, just look at it. Look. Tans, pies, sines, atans, tans, pies again, square roots, lots of brackets. All of that had to be in the right place and the right word. And look, I've only got one box to reference from. This degree here, and it tells you everything. It works out the whole lot and tells you how long your hip needs to be in the same relation that it needs to use the length of rafter. This is some of the working out. I was so happy when I finished this, and I really was, and I'm happy to be sharing it with you now. I could work out these hip and valley things. They're not incredibly hard to do. Once again, it's just using more trigonometry. These jack edge angles and jack decrements will take a little bit more working out. I've got to envisage some different triangles along a different plane for that, and I can do it. I will get there one day, but I don't need it at the moment. I don't need any of this. I needed that line there, which I literally could have copied out of the book I've already paid for and just used it. Either way, that runs through that other table and gives you back these measurements here. And I would be confident to cut a roof to these measurements, because I've worked it out how and why it's done the way it's done, and I am happy that, yeah, that's right. Either way, it's possibly a little bit of just showboating there. That I wrote it, I did it myself, and I was really happy when I'd done it. So yeah, I hope you've enjoyed watching me go through some of the code. If not, I'm sorry. We'll have to do it another time. But yeah. Bye.